After we creating after we create our mapping in such an action mapping and axis mapping, we need to create the function for our mappings. So we need some function that we wish to call it when the key are pressed. Add the following we will add the following function there. So let's use the void, and when E key press it, okay, press it, and that will call it when the E key is pressed. So, and next we need to add another one to is release it, and here we use void E key release, okay, and so this is the last one. We'll call each frame, and which value begin 0 when shift is up and 1 when shift is down. So let's do it, call it the shift, call it the shift, call it each frame, call it each frame with value begin 0 when shift is up and 1 value when shift is down. So let's, okay, nice, and let's create the function for that. Again, void shift key press, let's write shift key and float value and done. So now we need to use the quick definition. We create that, this one also, yes, and last one same. Okay. I'm going to grab this, all of them, and bring the end of our CCP file, and that's it. Let's continue in the next video. Let's add some information here. We can use our in our CCP. There is where I put oh, this here. In actor CCP we have a here. Like grab that and put here. So I'm going to use warning text, what text, E key press it, and next same for here, release, and the next same here, we go shift key axis value is F float, and that should be our value. yes, should be our value. This value should come here. Okay. Let I make a capital V here and also change here. Okay, compile it. So notice we commented the U log and in the shift key. Let us start from. Let's comment that here before the start. So we commented this is because the shift key, which will correspond to an axis mapping, will be called each frame spamming the output of the log. This will be make it difficult to see the message logged by the E key pressed and E key released function. We will first test those functions, then we will uncomment the shift key and test that one. So now that we have a function that we can bind to our action and axis mapping, let's do actual mapping. We need to add this following code under the check player input, and here action mapping. We're going to bind action is the function of U input component. Okay, so this action mapping, the bind action is the function of the input component. So we need to get this player because is pointer, and getting the bind action function because we add in our mapping E key name E key and IE pressed. Let's show here. So if you watch that bind action is a type F first pound and F name of action name and E input event. So this is our event, IE pressed, and the next we need to A first pound as a pointer object. So because this is the pound, and just only we using the object of this kind of in Python self. Okay, and the next we are using here our void pound pointer function. Okay, so here pointer our pound function, we need to add address of this function. So in this case I'm adding the address and first pound E key pressed C and function. Which function? This one. And next I can add for the second one when is released. Action mapping player again here. We action mapping when E key released. And this a function and this one should become here. Okay. This is our action mapping. Let's test that. So be careful, you should add include components, input components header here. The check macro is an assertion, a routine that checks the particular condition and performs an action depending on the check. The check macro in a particular will make sure that the argument passed in is valid and is not null. And if the check fails, it will halt execution. This is useful because if the value of player input component were null, we wouldn't have input binding functionality, and we would also attempt to access function via a null pointer, which can result in a crash. So the bind action function. After this, we will call the bind action function. The first argument, string literal, is the name of the mapping which we choose in our setting, and this is the case sensitive and must be an exact match to the name of given to mapping. The second argument is the enum constants belonging to the input event enum IE preset corresponds to the button begin preset down, whereas IE released corresponds to the button being released. The third argument is the pointer to the class on which is binding is occurring. This keyword returns the pointer to the current class in which it is used. The argument pass in the most always this. This keyword returns the pointer to the current class in which it is used. The fourth argument is a pointer to the function we wish to bind to access mapping, just with with variables. Functions themselves have their own addresses, which can be accessed with the address of operator. We need to learn how pawn possessions works. In the third person example map, there is already pawn. The third person character, this is the character that has come with the map by default. So right now we already tried E key, action mapping, and shift key as access mapping. We tried that. Let's add here scale 2 for left shift and right shift scale 1, and for this one I can delete it or I can add a new one. So for that reason they can stay here. What we can do here, add another one, action moving. In access mapping, this is the action mapping, such jump, for example jump. Let's add the jump. Let's add the jump here, and space bar. Okay, space bar, that would be our jump. Okay, and here for access mapping I'm going to add move forward. Okay, and for move forward I can add W key and scale 1 and add another one behind the S. Behind W is S key, and that can be -1. Okay, that will be 1. W S, it will be -1, and add another one. We can use up arrow, for example up arrow, up arrow, and the second one down for -1. Okay, and I think good enough for our keyboard. And then next I can add another action mapping for move right, and I can use D. D for, or A first. A can be +1, and the second one can be D cable -1. A can be -1 and D can be 1, and for the again we can use left button arrow, and this is right, okay, and left again -1, okay, A and left -1, and D and right 1. So right now we finished our mapping, but in the new version these are using the kind of AI system to create that, okay, and you will, if you download the third person, you will see that how they are using the node, and they are automatically mostly done already, but because we like to create this for our character, I try to use C++ for just simple move forward and right move function. So let's create the function for this action mapping. For simplicity's sake, we name the function move forward and move right respectively in palm.h. Okay, let's go find our palm.h. So palm, where is that? My palm, my first palm.h. So as you see here, in our private we create yes, here in our protected we can do another one for instead E key. I think we didn't delete that. No? Yeah, it exists. It can stay for temporary. Let's write call for forward or backward input. So in this case I'm going to use void move forward function, and definitely we need a value, float value, and next we need for side to side and void move right, yeah, move right, and I think move to side much better than move right. I want to change for side to side. For that reason I'm going to use here left and right scale, move forward, move side to side. It's so nice. Okay, cool. Grab it, come here and here, move side to side, move forward, and float value and semicolon. Definitely we need to refactoring, action refactoring, go to that and create definition for CCP. No, oh yeah, great job, and no crash, and here also definition, nice. So right now we have a two function, and we need to add our logic here. So if our value is not 0, okay, should do something to us. Okay, print forward is this value, and we have okay, cool. And again I'm going to grab that, put put here, and my side to side is that. So this is our logic for temporary, and let's see how should bind that. Going to, so now we have a function that will send the message to our outlog when called. This will be inform us that function are working. We also check to see the values if 0 0 first, okay, and that way we don't spam the outlog. And the last thing to do is actually bind those function to the axis mapping as we have done in input action and axis mapping section. So for that reason, we will go to use bind axis in our under here. Okay, we need to use bind axis this time, I guess. Yeah, we need to use bind axis. We need to use bind axis. So player input, component, and bind axis is our move forward, and move forward. Let add our I add, no it doesn't. So move forward, and this, and our address of this CCP, this function, move forward. We need to bind axis and semicolon, and for binding action, so we need another one. I want to add one function here also as a ePreset, and this time I'm going to use void space key preset and void grab and put here space key release preset space and space. So for let's define that call and other one also. Okay, definition, nice. Right now we should not see that green color there. So we have this one, nice, and spacebar. This can stay now. We don't need to repeat everything. Let's do that again. We E key preset on this time space and released space. Nice. So move forward, player input component. Really nice. Yeah, right now it's correct. It take a while to update that. And next we need to add the same for key press move forward. This is for move to side to side, side to side, side to side. Side to side. This time I am going to, this is not correct, value. Okay, nice. So side to side the same. Nice. I'm going to grab this one and put here. Okay, cool. Bind axis, move forward this. Should correct now. And let's add this point one, point action layer, input component, and bind action. And same as before, we need the name of the name action is our jump, and input event key letters key we will use here enum input event, and this, and our pointer t method pointer. We will use the address same as here. So let I grab the space key, press it, space key, press it. Oh, sorry, here we need to I'm gonna grab this. Okay, and here I'm going to use the jump. Let me check that is jump here. Space bar. I'm going to use jump here. Jump. Yeah. Now great. Jump. And enum, press it, and this, and semicolon, address, comma, and player again input. This time for move to side, yeah, and the jump, released, and grab this release and put here. So nice. Check that. Let's first let's do here comment our action mapping, axis point of E, where I shift key, let shift key scale to shift key, let I bind, let comment this too. At the moment I don't need that, and try it live compiling, and I will back. So we got error here, play component unclear identification, identifier, why? What's wrong? Yeah, this one, small to capital. Okay. Long and fire. Get rid of this. So move to side, start the printing. Let's see, stop it, and side to side, yes, because side to side is bind action, and we didn't put similar this in the state scope that start to okay, let's compile again. no, and okay, now let clear play and clear log. So now if I press W, see, and if I pressed S, that telling move forward is -1. Okay, okay, W -1, and for and for here clear and for D let me I think for side to side also with value we already done, and play clear. Okay, for W S and next D, yeah, A, true. Okay, right now that's recognize our function, and let's add logical again. Noise, everything happening now downtown. Let's play with the scales and moving the palm. Okay, let's move our palm. We now have a way to know when our keys are being pressed, and we like to actually move the palm, okay, to get the in response to this input. So for that reason I'm going to first of all in our palm I'm going to create a variable, use the U property, okay, U property, and U property edit anywhere, edit default only. Okay, we can use edit default only and create next blueprint read and write, and next we can put the category such movement, and the name can be float speed. Okay, float speed. Speed we can rename it as a speed scale. Okay, scale. And next we can create variable to store our x and y components of pound's direction, so we can get this x and y by vector direction. Okay, direction, and or let to use f. We can use 2D also. F2D. Okay, F2D direction. And now in our first palm, so speed is marked edit any default only to prevent the speed variable from being editable of in instance of the palm. It is marked blueprint read and write, so it can be accessed and set from within the event graph. Direction is marked visible anywhere, since we don't want to be able to set it on the details panel. Okay, and panel anywhere. So as this variable should be determined by key preset, we thus made it the same reason. Okay. So direction is the variable of the type effector 2D. Effector 2D is the similar effector, only has two components, x and y, instead of three. This is sufficient since we are planning to being able to move pawn in the y and x and y direction, but not z direction. Why? It's better I use. I'm going to use only effector. I prefer to use effector. I want z axis also, maybe for jump. Yeah. Okay. Cool. So next we will give the speed and direction default value in our constructor. So our constructor, let's put in our constructor, yeah, it's here. Speed equal, see, is recognized that, and speed is 500, and direction of f vector 0 0 0 0 and 0 0 f vector. Okay, nice. So these are the default value we give in the our constructor. Okay. And finally we need to store those store the value from move forward and move side to side in our direction vector. In move forward outside the if statement, we will add direction x equal value. Let's do here. In here, let's put here the x direction is value equal the value, and for this one let's put the value y. And the reason we are using the outside the if statement, because once they have a non-zero value, the if check would prevent them from being updated. Okay, now we must use the direction value and speed to move the pawn, and for that reason in the tick function we should add this under the super. We need to update each frame our location of vector. So if vector location and equal get actor location, and next f vector delta vector delta location, and delta location is equal f vector, okay, f vector direction dot x and direction dot y and direction dot z. So we need to use delta location dot normalized and delta location should multiply and for speed and delta time delta time. So location should be at another the delta location and set actor location equal location and get actor location. Here we normalized our delta location. Let I explain from scratch this part. So f vector called delta location and initialize it to x and yz component, and we use the function that belong to f vector struct called normalize it. What is this function does is scale the vector so that it has a magnitude length of 1. We do this because in the length because the event we are pressing up and right keys at the same time and the down and left, and the x and y component of the direction vector will be 1 or -1, and the direction vector would have a higher magnitude, higher magnitude. We use this vector to move pawn. We would get faster movement when moving diagonally than when moving left, right, up and down. So in the diagonal mode we will be that cause that we move faster. For that reason we normalizing. So after normalizing the vector, we multiply by speed and delta time. The reason for multiplying by delta time is because tick is called every frame, and frame rate vary throughout the game. This means that when the frame rate is high, the tick function call is called more often, resulting in faster movement. When the frame rate is low, the tick function is called less often, resulting in slower movement. We want our movement to be called by delta time, which is the time since the previous one. This way, when the frame rate is high, delta time is slow, and thus the delta location is scaled appropriately. Delta location have been normalized to be magnitude 1, then scaled by speed and delta time. Will be added to location. Okay? Vector and location will move in the direction of movement just the right amount each frame to keep smooth, constant movement rate. In fact, since location is changing by 100 units multiplied by the time per frame, the pawn location will move at the speed of 500 units per second, which is the value of the speed variable. We finally call the set actor location function, which pawn inherits from actor. So cool. Now everything good to go. So I think right now we have a pawn. We create in this video we create the pawn. Okay, and we have a move forward, we have a move down. Let me check again our set project. Direct. Let 1 multiply -1 and grab this and put here also. Let's see how it looks. Okay, now play. Okay, and move forward, move back, move right, move left. Now this is correct. Anyway, thank you for watching. We will keep going our video for next section. Next section will be talk about the character class, and right now we able to create actor, palm, and give the I'm able to map the be able to use the creating function for action and axis mapping. We can now start our character class. Thank you.